All right, we're live. This is exciting. Hey, thanks everybody for joining us today. I'm Stefano Bini. Welcome to part 2 of Generative AI in Orthopedics, a series of webinars brought to you by the Digital Orthopedics Conference in San Francisco, otherwise known as DOC-SF. We're in partnership with the Department of Orthopedic Surgery at the University of California, San Francisco, otherwise known as UCSF. I'm a professor there of orthopedic surgery. I do hip and knee arthroplasty, which means hip and knee replacements. I also founded the Digital Orthopedics Conference San Francisco and the Digital Orthopedics podcast, which will carry this interview, this conversation a little later once we get it all tuned up, and you'll be able to access it there as well as on our website. So I want to start pretty quickly into our next session, but first again, I want to reintroduce our panelists that some of you may remember from last time. So to my left here, Dr. Peter Schilling, MD, is Assistant Professor of Orthopedic Surgery at Dartmouth Hitchcock Medical Center and the Geisel School of Medicine at Dartmouth. Now, Peter is an Assistant Professor of Surgery, but he's also had a long storied career in digital health and tech. He does academic research, clinical orthopedics, and built and led and consulted several digital health companies along the way. He was formerly in Silicon Valley, where we got to know him. So now he's over in the East Coast. Welcome back, Peter.
Thanks for having me.
And Prashant Natarajan, who's the Vice President of Strategy and Products at H2O.ai. He's a healthcare professional, author, industry leader, and he's made significant contributions in the field of healthcare analytics and big data. And he's authored and co-authored books and articles related to these subjects. One of his most notable books, actually, is Demystifying Big Data and Machine Learning for Healthcare, which is right up our alley. And his co-authors explored the potential of big data and machine learning to revolutionize healthcare by enhancing diagnostics, treatment, and patient care, which is, of course, a lot of what we're talking about today. Welcome back, Prashant.
Thank you so much, Dr. Biddy and esteemed co-panelists.
Awesome. And then Unity Stokes joins us today. We're super excited. Unity is a great friend of mine. He's a co-founder of Startup Health. And Unity loves to talk about the fact there's a mission to improve the health and well-being of everyone in the world, which is awesome. In 2011, he co-founded Startup Health to organize, support, and invest in a global army of health transformers. We'll hear more about that as we go on. Unity believes that anything is possible by combining the power of moonshot thinking, a health transformer mindset, and collaborative innovation. Welcome, Unity.
Great to be here. Thank you.
Awesome. All right, guys, we want to follow up on our amazing conversation we started last time. But I do want to sort of summarize briefly by saying that on our last session, we talked a lot about large language models, and we touched, Prashant, on the idea of how to make these accessible to people, because right now it's not necessarily accessible to anyone. So what I want to start with is this idea of fine-tuning models. So we start with a large language model. It could be Bard, it could be Llama, it could be any of them. But at the end of the day, they're general models, right? They're not really applicable if you ask questions to a very defined specific task or knowledge data set. How does it happen that we can create what is called a fine-tuned model? And would you define that for us, Prashant?
Sure, and Stefano, I would like to do that by actually going back again to fundamental basics, right? So I'll take a very simple example to explain things such as fine-tuning, etc., and then we'll see how it relates back. So fine-tuning is really, I would say, the Joe and Jane definition of fine-tuning is teaching manners to your child. Let's assume you have large language models as a child. You have taught it basic morals and so on and so forth as part of education. Now you're taking the child to a formal dinner. And then you want to now educate the child on certain things, adding new knowledge to an existing model by updating the parameters is fine-tuning. It's not tuning trade-off, but it's bringing new knowledge to the table, but actually updating the parameters of the model, right? And it's not retraining per se. So what it means is almost like, to take a very simple example, is to take a child who knows basic manners, morals, etc., and teach them how to behave at a 9-course English formal dinner. which means you hold the fork on this hand, you hold the knife on this hand. Now, what's the challenge with it? If the child is a very young child, doesn't have enough experience, hasn't been fine-tuned, could forget. And which is what we see, right? Sometimes it works, sometimes the child forgets, and you get the horrible child back.
So we did explore this idea of a large language model as a child on our kid. Everybody wants their own kid and want their own kid to speak their own language, etc., and the complexity of training it. And that's reasonable, but let's make it a little more practical. So what does it actually look like if
Stefano, if I could just interject here, because some big things have actually happened even since your last discussion. So for example, Bard in the past few days has integrated the ability to search your own personal data, like your Gmail account, your Google Docs. So all this data, this new pool of data, your own information, I have basically 20 years of Gmail, for example, is going into the ability to fine-tune Bard. Another thing.
Actually, before you leave that thought, Unity, now everyone's gonna sit there and go, it's great, but I don't want to train Bard on my data. I don't want to know anything about me, but that's not really what happens, right? When you say it's going to access your data set, what we're talking about is like, actually, it's already tuned. It's a child that's already a college level grad, so not quite an adult yet, actually, but it's going to be looking in your data for information, but it doesn't necessarily keep it or own it, right? That's important to keep in mind.
You know, there's actually a debate about this very topic now. Some people are very excited to turn that feature on. A lot of people, including myself, I'm going to wait a little longer. I want to see exactly how the data is going to be used and really have a little more clarity on that point. So this is an open debate. We're talking days that feature has been out on the market. So these are the types of issues that are being addressed, talked about, debated almost in real time today. I do believe that one of the significant issues that will be figured out, and if you read everything that Bard has put out, you do get to control your own data, or at least that's what it says. But if you also look at a lot of the discussions, they don't necessarily know how this data is even being baked into the model or leveraged by these models. So it's open for debate.
By the way, the last Prashant, go ahead.
I think some things are open for debate. In general, yes, the space is early enough that everything is open to debate, everything is open to discovery. At the same time, I didn't want to bring up a specific example of a specific product, but since we have opened that door now, H2O AI has been building and delivering this for 6 months now. We went with fine-tuning. We put out our fine-tuning studio that is open source. And we found that fine-tuning is not sufficient. So we have been significantly working with RAG, retrieval augmented generation. We have been working with the finer points of vector databases, embeddings and vectorization, graphical corrections, etc. So if you really want to understand state of the art, yeah, absolutely yes. Fine-tuning is not exactly state of the art, given the pace at which things are happening. What we have found is if you take a look at a foundation model, the best way to put that model to work on an enterprise data setting is actually to be able to create a private and a confidential model, sometimes using one document or one source as the case might be. We have done that. We have been able to add references to every fact that is pulled out with RAG so that there is little to no hallucination. And in fact, we are almost able to come to zero hallucination. Brave words, I know. But that's what happens when you're not generating facts, when your facts are retrieved and attached to text that is generated, you get significantly better results than fine-tuning. So if you really want to understand state of the art, an LLM system, a generative AI system that requires the retrieval of facts, the augmentation with other facts or structural elements such as fine-tuning, and finally, generation at the last end of it is giving us dramatically better results, which we are testing across multiple enterprise customers than some of the things like fine-tuning, which was the only option we had 6 months ago.
Okay, let's try to bring this put a little bow on this. The question was asked, these large language models need to be trained on specific data sets. And Bard and others are making this accessible. You say, look, this is my data set, go look in there. It's becoming, it's not as accurate as we thought it was. So we're starting to learn these new techniques to access this information, and we call it RAG. You mentioned that, so let's come back to that, but that's retrieval augmentation concept. So it's both the retrieval augmentation, and what you talked about is saying, look, we don't want the AI to sort of come up with the whole thing generated. We want to go look for a specific point, not change it, deliver it to us in a way that we can access it and reference it, so we know exactly where it came from, and then put it in context so we can understand it. And that's what the model does, the generative part. So what you explained to us, Prashant, was that we're now getting closer to this ideal situation. We can leverage these models to access information, explain them to us without running the risk of the data itself being compromised or hallucinated on. Did I summarize?
Yeah, you got that spot on. The only thing I would say is there may be some hallucination given the nature of large language models. We can't get rid of it, right? Sometimes hallucination is a feature, not a bug of LLMs as they have been defined in foundation models. So it's trying to control that. At least you cannot hallucinate with facts. If you want to say could instead of should, okay, not a big deal.
Okay. Peter, are you going to turn on this feature?
Live on the EHR? Probably not quite yet.
On your email. We'll come back to foundation models in the EHR.
Yeah. Yeah, no, I'm joking. I think it's really compelling, right? The notion that this is just use cases that aren't even specific to healthcare. If it can solve my personal problems of even just travel, of being able to book a flight or look up my information about where what my travel agenda is, or if I could ask it more general questions based on what you know about my 2 decades of email, what should my next career move be? It might come up with some fascinating answers. I think, like so many things, it's just so soon to tell, and it takes a lot of tinkering. You got to just start playing with the stuff to see what it does.
Unity.
That's actually a very important point. The reason I would turn it on is this reinforcement learning concept I know you've spoken about, which is every time I play with it or use it or respond to it, it gets smarter and smarter quickly. So tinkering around with it would be the exact reason to dive right in and make your own personalized AI smarter and work better for you. And in fact, I believe that's why a lot of companies are now going out and opening up these models to the public in a more, a larger way, so that they can get millions more people reinforcing them, learning them, teaching them, training these AI to be more effective and more intelligent.
I think that's a really critical point, even from a product perspective. The notion that without that input from millions of people, that one's going to understand exactly the great use cases for it, you just can't do it. I think you've got to release it out into the world. It takes some guts, I think, to do it, but I think it's a great path forward.
So okay, I'm a geek, all right, fine, I get it, it's okay. I think that for our audience, it might be helpful to, for a few seconds, maybe a couple of minutes, talk about the various ways these things learn, actually, so we understand the nuts and bolts of things like reinforcement learning. What does that mean? Dynamic training, few-shot learning, zero-shot learning, only because these words are coming up a lot, and it's good to understand them in context. So, Peter, you want to take a shot at these, or you want Prashant to do it? Or I was thinking maybe we could talk about specific about reinforcement learning. You brought it up. Let's talk about what that means.
Let's have Prashant start with it from a technical perspective, and then I can chime in with the gross generalizations that Prashant and others can correct.
Well, it's again, I'll keep it simple, right? Just given the fact that if folks want to go into more detail, I think the sources, including my books. But at the very basic level, what is reinforcement learning, right? It's been around for a long time. It's really deep learning as it's underneath, and also leverages a lot of the transformer-based architecture we talked about in the last webinar. Reinforcement learning is simply, as the word suggests. Again, I like to always start demystifying complex topics into the simplest language and then add detail. So reinforcement learning is teaching reward and punishment behavior. So basically, if, again, I'll take the child example. If the child reaches out for a piece of fruit, you give the child a kiss or you rub its head, that's positive behavior, great, right? If the child reaches out for a piece of candy, you show a sad face and hope that the child recognizes that sad face means avoid candy, happy face means eat more fruit. Now, will the child pick it up? That's a different conversation. We won't go into behaviors, but that is reinforcement learning, right? When you if you have a dog at home, as we do, and you award the pet with a treat to enforce positive behaviors and also differentiate between negative behaviors, you're reinforcing certain behaviors and you're improving the risk reward function. You're improving the rewards when more of those behaviors happen. So when you have an AI system where the preferred behaviors get repeated more and the reward function encourages it to happen more, you're reinforcing certain behaviors as based on new data and new learning. So that's actually the foundation of reinforcement learning. It uses a bunch of.
And I'll jump in a bit. Correct me if I'm wrong, but I want to jump in a little bit. And that is that the reason it's so critical, specifically in generative AI, is that this is a technology that's coming up with creative correlations between things and needs to know if that idea they brought up makes sense contextually, right? So the reinforcement learning provides context, but also provides reward to the software, so it keeps bringing up more of that. So that's reinforcement learning. What about dynamic training?
Oh, I wanted to add maybe something about the reinforcement learning, because I think there's an interesting point here for folks who aren't hands-on keyboard and deep in this. It wasn't that long ago that I think it was Tesla hit a parked airplane, right? And kind of funny and so forth, but why did it do that? Well, it hasn't encountered those examples enough is maybe the most simplistic way to do it. But I think what it also highlights is the different way of programming computers now. Back in the day, if then statements, some engineer would go in there and fix it. That's not what happens now. And Prashant can correct me on details. Basically, it's learning through that experience. You have to give it that experience and even either reinforce the behavior that, yes, brakes should be applied if you see an airplane-like object or not. And that's profound, I think, for the clinical audience, because I think it also highlights the importance of experts within the domain, because they have that expertise, the context of what may or may not be important and how that thinking happens. So to me, it brings clinicians in when it's a healthcare specific use case.
I completely agree with Peter. That's exactly right. It's figuring out from the reward functions and other things that this is the better behavior, and it's encouraged and actually updating itself. It's not a rules-based system, right? It's a feedback-based system. So reinforcement learning is the process of managing rewards. Then there's another word which we hear frequently, which is reinforcement learning with human feedback loops. And we come across this again and again. So you asked also a question, what is dynamic learning? Dynamic learning is really utilizing human feedback loops. Bob Rogers and I talk about this at length in our book a few years ago, which is we pointed out at that point that it's only feedback that makes an ML AI system usable in healthcare. Until that, the feedback has to be of two types. It has to be stop, don't proceed further, or go, this is good enough. Or it has to be go back to school and learn your manners again, right? So that human feedback has to be super, super important. But then what we also find is just human feedback is not enough, because humans tend to do a very good job at recognizing known unknowns. Humans don't do a good job recognizing unknown unknowns. So how do you ensure that happens? Because when you're building a system like this at scale, especially a language model, there's so many permutations and combinations and things that can happen. So the final piece, Stefano, that is truly revolutionary that's happening right now is adversarial machine learning. And so we talked about reinforcement learning, we talked about dynamic learning. Peter touched upon the fact that the human feedback is more important than anything else. But the last part is use autonomous agents to try and break the system. Adversarial machine learning, as the name suggests, is using AI to create an adversary. And the adversary's job, the challenger's job, is to break the champion. The champion's job is to fight back. And this is happening at billions of combination levels, right? So we are fighting, and at one point, the competitor becomes strong enough, the challenger becomes strong enough, it beats the competitor, at which point that becomes the new champion, right? So I think these concepts are all tied to each other. And they are truly pushing the boundaries of what we can do with this kind of AI in practice.
Awesome. So the reason I wanted to bring up the learning piece is because contextually we start with these big models that were trained on the internet data. We need to make them make sense to us, so we train them on our own data. We get that information back to us in a way that limits hallucination. So far, so good. But we need to keep that data set updated. One of the frustrating things for me on ChatGPT is it always says, I'm only good up to 2021, whatever it is, and I want current data, right? I want my data. So you have to teach it. Now, what happens with the FDA in healthcare is that it's going to approve a model based on what it is, but that model needs to change to remain relevant. And so, and I was going to bring this back to Unity, how do we stay on top of these models so they can continue to learn, be domain adaptive, and other terminology that we use in the space, and actually keep them safe? And then if you're an investor, how do you look at that and go, I don't know if you're going to continue, if you're going to go out today, how do you, and you invested, I don't know how many millions of dollars to train that model, how do you keep the money going to keep it active? I mean, how do you look at that kind of question about keeping that model accurate and up to date, Unity, as you're investing in companies?
Well, I think we should step back and just talk about two quick things. First of all is the moment we're in. First of all, a lot of work has been done over many, many years. So I would argue, for example, what DeepMind did for medicine and science several years ago is still the most significant thing to happen as it relates to medicine, and really AI still.
Do you want to mention what that is?
They solved the protein problem and mapped 200 million proteins that they open sourced and are now being leveraged by clinicians, scientists, researchers, pharma companies, etc., to solve.
Just for drug discovery, right? We've had
drug discovery.
20 new drugs go to the FDA that were discovered completely on computers. Yeah, absolutely amazing.
And the second point is the exponential pace that we are moving. The speed of innovation is happening in days and weeks now, not many years. So the point you're bringing up, I think, is profound and significant, which is how do we keep pace with these types of innovation cycles to keep people safe? One way to do that is to start introducing more of the clinicians and practitioners and all of the folks here watching into the process of using these systems, being a part of the reinforcement learning, for example. So the more folks we have involved, the smarter it's going to get, the safer it's going to get. So that would be just one reason why I hope more of the medical community, the healthcare community writ large, is building on top of these systems.
So your excellent points. All really good. But to get back to the question of models that are constantly being updated and need to be kept on top of, and trying to figure out how to. Prashant, it looks like you have something to say on that.
Yeah, I do, because at H2O, these are the problems. I'm not doing a pitch over here, but this is what I work on a daily basis at my company, right? So we are building the products that do this. We are not doing advisory here of other people's work. So we are in the heart, nuts and bolts of this. We are working with all the top healthcare organizations in the world, right? So I think it goes back to fundamentally, in addition to what Unity said, which is super important. The human feedback is the most important feedback. And we also tend to forget that an AI system in health and medicine is never truly AI. It's never artificial. It's assistive. It's augmentative. It is amplified intelligence. It's not merely artificial intelligence. Artificial intelligence without human direction and human approval in health and medicine is not going to cut it. So having said that, and again, don't want to get into too much of a soapbox moment, to talk about what you're talking about, using LLM ops. Just as we had the concept of ML ops and machine learning ops, where you use AI to track data drift, concept drift, things where data changes, concept changes. We are also working on the field of LLM ops quite a bit now, and we have LLM ops offerings where instead of tabular data, we are actually tracking how embeddings change. We track and update tokens. We are looking at the changing semantics and changing templates that we may still come through. And it's a bit of early days, but look for LLM ops to really pick up a lot of steam in the days ahead.
By the way, I just want to clarify a couple of things. So data drift. If you I think I can't remember which big university trained a large model on their data several years back. 3 years later, the data was no longer accurate. Same medical center, same data set, same people, and that was called data drift. That's sort of what we're talking about. This was somewhat new to me recently until I learned about this. That the ability of a model to remain accurate on a similar, if not identical, data set actually changes over time. And you mentioned semantics. It's actually quite complex. So it is important, as you said, to stay to remind ourselves that this is a dynamic environment. These data sets are not static, and that the way that they're interpreted changes, probably as a reflection of the fact that we ourselves are changing the way we treat patients. So I also really like what you just said about how it's not really artificial intelligence. I want to reiterate the words you use if I can remember. It's augmented intelligence. It's
amplifying intelligence. It's assistive intelligence.
And that's important for us doctors to hear. Peter.
Yeah, I have thoughts on that as well. And this is something that I pull myself back to if I feel like I'm getting lost and, anthropomorphizing too much. Think of these approaches like a telescope or a microscope. The unaided human eye cannot see bacteria. The unaided human eye cannot see Pluto unless you're looking through a telescope or looking through a microscope. An algorithm, these models, whatever, all the lingo, the word salad to people who are outside of the world. It's an instrument of knowledge magnification. It's an instrument through which to navigate knowledge. Now, how can we use it? Just like struggling to find the applications, the microscope, the telescope, and also being wary that there's aberrations, right? A lens can be flawed in your telescope and you can draw the wrong conclusions. And so that's what we're talking about, is the aberrations. Is that in the data? Is that in the algorithm? So coming back to that, I think kind of helps me recenter.
Okay, I'm glad we went down that rabbit hole of how these things are trained, how they collect data, the impact they have. I want to spend a few minutes on value. Unity, we spent some time with Ben last time talking about what his investment strategy is. He actually hasn't, so I remember correctly, invested in a full AI company. You've invested in a lot, so different perspectives on where the value generation is. I just wanted to shift a little bit towards value generation, and then Prashant and Peter, I want to move a little bit towards the strengths and weaknesses of these LLMs, things like energy use, etc. So we get a bigger step back even further, understanding how these tools sit in the ecosystem of healthcare. So when you're looking, picking up on a little bit here, when you're looking at this crazy pace of innovation and all the applications you see that are proposed to you, how do you evaluate the value proposition brought to you by an idea as it comes to the table?
Well, first of all, we never just look at the technology for the sake of technology. You want to look more holistically to how the team is actually going to be leveraging these technologies. And I would say over the past year, it's changed quite significantly. So a decade to 12 years ago, when we first started investing in AI as it relates to healthcare, we were looking at companies that were leveraging AI for things like drug discovery. In fact, in recent months, our company Cyclica, which we invested in about 12 years ago, was just acquired by Recursion Pharmaceuticals. They're focusing on using data to speed up the drug discovery process and cycles. Now, though, when we look to see how a company is using AI for themselves, whether, for example, internally, to help them code, to help them speed up, be more efficient, and just be a better company. So it's almost a non-starter if a company is not leveraging these tools that in terms of operating their own business. Now we're also looking just how they're integrating these new tools into your own strategy. So, for example, I believe we're at a moment that's similar to the mid-90s, where I would go to conferences and feel very much like everyone was talking about interactive CD-ROMs when I was over working on this thing called the Internet and the World Wide Web. And we're very much at that point now where you're either going down the path of where the future is going, or you're stuck in the past. So we look very much to see how the CEOs, how the teams are thinking, and how they're using these new tools, both internally, but also designed into their solutions.
I think that's brilliant. Thank you. There's tendency to think of AI as something you do or you sell, or it's a feature of a product, as opposed to thinking about it as a way of being, a way of doing business, a way of structuring your company. I think the idea that it's part of the DNA of a company that should be leveraged to maximize its ability to deliver on value downstream is really great thought process.
At the same time, Stefano, yes, I will say one thing, right? I do agree with Unity 100% of the fact that, what are the challenges we face on the other side, right? Everybody is an AI company now. The person who is not doing AI is also an AI company. So the one complaint I'm hearing a lot from physicians and health system executives is almost everybody is claiming that they have AI today. So before we get to value, I think one of the first things we need to do is kind of put some guardrails on what AI really means before we let the snake oil come in. I'm sorry, strong words. But we are at a point where AI snake oil is probably more prevalent in front of users and buyers than real AI. So I think before we get to how we determine value, I think there's a desperate need for us in health and medicine to really figure out and put some guardrails in place about what is AI and what are you selling us before we actually try this out or implement it.
All right, tell you what, take a shot at it. Put some guardrails on it. How would you define it? Peter, it sounds like you want to take a crack at that too.
Well, I was going to put a little different angle on it. I would just kind of underline how a company doesn't have to make consumer-facing products or products that maybe a healthcare provider interacts with. Screws up. It looks stupid. But if you do it internally, you get a culture around it. You start to understand how these tools work. Things that go wrong don't necessarily have to be a massive safety issue or a big embarrassment. So I think that's an important avenue. But yeah, let's go back to your other question though. And Prashant or Unity, what are your thoughts?
So guardrails, back to guardrails. Well, what would you? Another way to think about it for our audience is how do they evaluate a company that says that they're, AI and maybe they're not. So just a couple of things. Actually, Peter and Prashant, I do want to double down on this point you just made, Peter, that sometimes the biggest value for these technologies may not be right at the cutting, bleeding edge, especially in healthcare, of diagnostics and therapeutics. It may be on the back end of administrative purposes, running the hospital, decreasing repetitive tasks, increasing the accuracy of repetitive tasks. May not be very sexy, but it is very effective. So having said that, let's go back to Prashant and your idea of guardrails. So what kind of guardrails are you thinking about? Explain it to us a little bit.
So I think, again, you can break the guardrails into governance topics. You can break the guardrails into functional topics and technical topics, right? Governance actually applies to the entire organization. Where can you use a foundation model? Where can't you use a foundation model?
You said governance, not government. Governance.
Governance. Government has a role too, but we don't get into that.
Let's get away from governance. Let's take the governance.
Governance, right? AI governance, just like data governance, but also AI governance is more than data governance. It's data governance, governance and monitoring of models, like we talked about previously, but also user governance. which is enabling this ecosystem where people can rapidly do experiments without too much guardrails. But stuff that goes into protection, that goes and influences some part of the workflow, is actually tightly governed. So that's one thing. Technical guardrails, I would say that in healthcare and life sciences, we must demand more in terms of interpretability, explainability, transparency, and security. And these are four important things, which unfortunately, I think most of the large players today are not looking at these. It's almost an afterthought, right? So I would say whoever you're working with, demand more in terms of, no, it's not good enough. You can't get away by saying hallucinations are the nature of the beast. What are you doing to fix them? Right? So I think users must demand more. If we don't demand more, people will sell us the state of the art, right? So I think that's one thing. Third is, I would say, just from an organizational perspective, look for somebody who's been there and done that before, right? Everybody is an AI company today. I just made my bread this morning in an AI toaster. Does it have AI? Of course not, but that's what it says on the cover. So go with folks been there, done it before, people who have a history of doing it, and not somebody who has just discovered AI because it's the fashionable thing that there are budgets for today.
Yeah, I'd underline that as well. I mean, I just, and this is more the VC that we have here who can probably speak to this. I just want a simple statement. If a company comes to me, we do X for Y by doing Z. What do you do? You know, how do you do it, and who are you doing it for? And if you can't express that in a simple sentence, I'm pretty concerned about that company not really knowing what they're focused on. And that phrase doesn't have to necessarily, I prefer it not to include the word AI.
Unity. Feel free to answer that.
Yeah, we never go looking or even really asking about AI. We're looking at what they're building. What are the outcomes? What's the problem we're trying to solve? What's the health moonshot we're trying to solve, and how are we doing that? I'm much more interested in what I would call the full innovation stack. So how does AI mix with your hardware, mix with your business model, mix with your design, mix with your user experience, etc. So within the context of healthcare, it might be looking at the workflows. How are we being more efficient, for example? In the case of a product, it might be how are we analyzing the data, and how are we doing that more effectively with the new AI tools that are out here? So it's not within a silo, it's more within the context of the problem we're trying to solve, or the product that we're delivering to the market.
You've also talked about the importance of AI becoming an invisible tool. What does that mean to you?
Yeah, consumers, clinicians, people, the best innovation should be invisible. It should disappear into the background. No one cares about the AI. They care about, are you solving my problem? So I would argue there's been actually a lot of AI integrated into our lives for many, many years now. All the algorithms on the social media platforms are AI driven. The first contact has been through platforms like YouTube, Instagram, Twitter, etc., that are designing, much like the e-commerce platforms like Amazon, what you see, when you see it, why you see it, based off of what you've done, what your data, what your patterns of the past have been. These are powerful AI systems that are analyzing these massive data. Within the context of healthcare, there's been a lot of this as well. We talked about drug discovery, but there's some really exciting innovations going on. And for example, how these systems can analyze your own genome, for example. If you look at a company like Human Longevity Inc., Health Nucleus, for example, whose goal is to mash together all your personal data, from your genomics to your MRIs, your CT scans, all your blood diagnostics, and essentially try to predict how you might die, so that you can then prevent your own death. For example, identify a stage 0 pancreatic cancer, early Alzheimer's, these types of things. The opportunity to leverage AI integrated into the actual innovation or the full stack innovation becomes quite significant. And we're starting to see this. I would say we're very, very early within healthcare. And what I believe is we need much more innovation today in terms of how these tools are going to be used by clinicians, by the healthcare market writ large. And this is where we're going to see, I think, a lot of the conversation shift to really how valuable AI can be for the world. So instead of delivering up better ads or better e-commerce to click faster, maybe we can solve problems like different disease or cancer, or supercharge a clinician to make their surgery more effective, etc.
This is great. I want to take this to the next logical step as to why that hasn't happened yet. Now, it sounds like a stupid question because it's so new, but we've been dealing with Siri. We've been looking at AI that's serving us ads for quite a while, very effectively. So why has it been so ineffective in healthcare? Now, let me just take a step back, and Prashant, correct me. And it's back to value. It's actually where I was going with the whole value thing, which is this. If we were taking on a multi-gazillion-dollar problem, which is selling ads to the internet, it's easy enough to argue that we should get 500 engineers, super expensive, top-notch people, put $10 million behind them because the ROI is so significant. You can develop these massive algorithms. Oh, and by the way, the data is there. There's enough data there to actually make these things effective. If there's an aside that Google just released a new text-to-image based model, and it's very cool how they showed how it works. They showed what the outcome was when they gave it, I think, everything from 80,000 parameters to start with to 20 million, and you showed how much better the image generation got every time they added more data to it. My point is that in healthcare, we don't have that kind of data yet. We don't have enough data possibly about specifically pancreatic cancers in white males in New Jersey, which is different from pancreatic cancers in females in some other part, that we can probably generate those kinds of insights yet. Is that
Maybe, because I think anytime we bring up cancer as an example, we kind of are taking the moonshot disease, right? I mean, even with something like breast cancer, which is such a well-studied cancer relative to pancreatic cancer, we still don't know about triple negative breast cancer, right? My mom, she survived. She had a spinal cancer that has been only recognized in 300 people in the globe in the last 75 years. So I think it's very tough to take this in terms of cancer and oncology, actually. So I think we should think about more population use case, more primary use cases, right? Bringing the right patient in for a screening for prostate cancer. That is much easier. Or pancreatic cancer, right? So in the scheme of things, but I'll go back to your question, which is a very important question. Why haven't we gotten as far as we have in healthcare? And again, I'm not, you know me, Stefano, I'm not going to, I'm going to speak my mind, right? I think there's three fundamental reasons why we are not able to do it. And I don't believe it is a paucity of data at all. It may be a paucity of data interoperability, where the data is not shared evenly, but it's certainly not a paucity of data. So I would beg to disagree on that, right? But I think there are three more reasons more than data which prevent us from really making the progress our patients and our physicians and clinicians deserve. First, healthcare, relatively speaking, is a low-margin business. Unlike ads or banks, the average health system operates at a low single-digit margin in a good environment. In a bad environment, it's not even single-digit. It's a 1%, 2% margins. These things cost money. They cost money to develop. They cost money to also bring about the last mile. So I think a huge challenge with health systems, academic medical centers, simply put, is the fact that we don't earn enough and there's not enough support from the federal government and state governments for us to actually put this to life. Just as we did with meaningful use and stuff like that. If you really want AI, I think it has to be a public-private partnership. It can't just be each hospital which is managing on 1 to 3% margins to figure out where they are going to pull money from patient care so that they can participate in the AI revolution. I think that's the first big problem. The second big problem we have is because of a lack of typical solutions, a lot of hype, not enough responsible AI, not enough interpretability, not enough explainability. Then it really begs the question, so how do you actually, in banking, when we use AI, the regulations are so strict, we have to be able to explain why we denied a credit card application, right? Are we going to then basically say, no, we didn't treat you for sepsis because our 53% accurate model said you don't have sepsis? No, we can't. The cost of that decision in healthcare is much more severe. So the lack of interpretability and explainability leads to safety and alignment challenges. In healthcare, if you give me a wrong ad on Amazon, I'm going to leave a negative review or I'm going to curse you. If I'm going to kill a patient, there's no going back. So I think that's the second thing. The third thing, going back to one of the comments that I think Peter or Unity made, is we still approach AI in healthcare and life sciences as a widget. We don't look at it. I always say, like, AI should be invisible. Not only should AI be invisible, AI should be impactful by being invisible, because that drives the last mile. The last mile change in healthcare is 10 times more difficult than the first 99 miles.
I would add there's three practical reasons. One is obviously safety, risk, liability. We're talking about healthcare, not delivering ads, as you alluded to. The second is we're just early in the cycle. Healthcare's lagged to leverage technology writ large, let alone AI. And I think that's okay because of the safety issues. So we're figuring a lot of things out in other industries that in the future will be leveraged by healthcare. But I think there's a third very important, just practical reason. When I go to Cerebral Valley here in the Bay Area and go to hackathons or events, or there's a lot of technologists, there's never clinicians, there's never healthcare practitioners. So I think there's an opportunity and essentially a requirement, a need for more clinicians, more medical practitioners, more healthcare leaders to be infused into the innovation process at this early stage so that we can design for healthcare, leveraging these powerful tools.
So that's the whole idea of Digital Orthopaedics Conference San Francisco, is bring these together. We should do a hackathon next time. Peter.
Yeah, I agree with all these comments. These are spot on. One that I run into, and I've run into personally, and then I continue to run into now that I've switched over back to academics and providing care, it's data ownership. And I feel like that's a nut that still needs to be cracked. One of my companies was data interoperability in the ICU. And so interoperability, critical. At the same time, then our company struggled because we couldn't get our hands on enough data to do what we wanted to do with it. So what did I do? I threw the rudder to the side as hard as I could and pivoted back to clinical work because I wanted to be on the other side that held the data. Problem is, you still run into the same issue. So data, hospitals don't own it. They're the stewards of the data. Patient, do they really own it? No, it's theirs, but I don't know if ownership's quite the right word. So if a company wants to innovate, and say it's a big company, and these are some of the companies that I speak with, that's what they do. They develop products, they develop services, and they need that data to create that product or service. Now, who benefits from it in terms of making money off of it, right? Hospitals cling to that data because they've been told data is the new oil, all right? And so they don't want to give it up. It's not oil. Oil is a commodity. Data is use case specific. And so they cling to it thinking, well, this is valuable, we're not going to give it up. Same time, hospitals are not designed to create products or services. That's not their role. They're providing care. So what do? Who benefits when that product's created? Should a large healthcare company make all the money from the algorithm that cures cancer? Should a hospital get some share in that profit? What about the patients? They donate the data. So to me, I'm not clear at all on how that works. And maybe you folks have other ideas.
Well,
I do have another idea. I'm a strong proponent of patient benefiting from monetizing that last part which you mentioned, right? So I think what we need to be careful about is, given the nature, and I don't know if it's possible or not, but this is my hope. What I want is for every one of us in America and around the globe, if our data is being used by AI, we don't create the Henrietta Lacks moment and disenfranchise billions of people to benefit some algorithm or some entity that's now going to also decide our healthcare future as if we are some ad widget. I'm not trying to be dramatic here, but that's exactly what we have to guard against, right? There's a move towards the commodification of healthcare and a move towards converting healthcare into completely an economic activity on par with ads. We cannot allow that. And the way we cannot allow that is to put demands and requirements on the players to use AI responsibly. And yes, the data that is used in health AI has to be treated as a commons and not as proprietary knowledge by any one company.
At Dr. Seth, we explored the idea of using the blockchain to support that, but let's move on to Unity. I think you had a thought there as well.
Well, I was just going to add that I think this is where the global opportunity is so significant. Prashant, you mentioned billions of people. Billions of people have absolutely no access to any type of care whatsoever, yet they have connected devices and cell phones. So I believe there's a significant opportunity to bring millions of, or billions really, more people around the world, essentially tools to give them their own, access to something they have zero access to now, which is health information, health resources, and the modern day era of science. So I believe there's going to be a ricochet effect. I believe that billions of more people very quickly, much more fast than we thought even a few years ago, are going to get access to care that they did not have because of these platforms, because of these tools. And I think that's a good thing.
So, and that might bring us more data. I disagree with you guys. I don't think we have enough data in healthcare yet. And that's not because the data is not there, but it's not accessible. But the minute we do bring these people on board and we get that data, make it accessible, then maybe we will be able to unlock the full potential of this AI. So it's interesting to me to go down rabbit holes, but I'm wondering if I should. I was going to go down the rabbit hole of synthetic data. And the reason I do is because it's one way of generating data without actually having enough source data. And the reason I mention is because when you get that into use cases in healthcare, as a rule of thumb, Peter and I as clinicians, not only is our perspective on the world really, really biased by our experiences, but it's also really, really narrow. Peter and I both specialize in 2 operations at the end of the day. We can do more than that, but we do 2 things, and our minds are focused on those data sets and those questions, those articles. But at the end of the day, it's pretty narrow. And so in order to create enough data to create an algorithm that it's actually meaningful to us, we may not be able to collect the data set necessary to surface those insights without help. And the help that I'm seeing, there's a great paper I just saw recently on this. It was is synthetic data. Now, synthetic data is data that's created, but statistically is equal to a data set that could be native. I just mentioned what they did. They took a CT scan, and from that CT scan, they were able to create X-rays, and they used those X-rays to then train the model on things that didn't have enough X-rays for, and then showed those as accurate as if they trained it on real X-rays. So these technologies that are amplifying the ability of these technologies to make up for issues that we have are really looking exciting to me. Peter, you have, what do you think?
Yeah, I have thoughts on it, and I want to put this out there because I want the technologists to push back on me. I fundamentally sort of don't get it, and let me explain what that means. To me, accuracy is not a great metric for these models, and I've heard this, and his name escapes me, He wrote a great paper about it. Italian guy, Stefano may know him, was at HSS. And so what that's hiding is extremely important. So those rare instances of I don't know what the scapholunate dislocation, I mean, it happens, but it's not as common. And so if you make synthetic data from some, body of imaging, and you don't have enough of those, are you still going to have enough of those rare edge cases? And then your accuracy, sure, looks great, but when the devil's in the details, what I care about, I mean, I can see a femoral shaft fracture. Yep, it's broken, but I might miss something in the hand. So to me, that's what I don't get about it. All right, you guys take over.
No, I trying to have a objective view towards this. The challenge that folks have is because of PHI, PII safety. Synthetic data is often the only way for someone to get started, right? So I'm all supportive over there. If you've got nothing else, go ahead and use synthetic data. Here's the challenge though. You can't do much with it beyond an experiment. Beyond the reasons Peter mentioned, nobody takes the results and the insights seriously. They're like, oh, how do you know you haven't caught that? Well, how do I know? Because I've created a synthetic equivalent that has a statistical significance compared to the original data set, which is good. But it doesn't mean necessarily anything beyond that. The second challenge you have with synthetic data is just the attitude around the use of synthetic data means that you can't take things to production. Nobody treats it seriously once you complete that model and try to put it in practice. So for those practical reasons, I would actually say that a deep learning on synthetic data is today's equivalent of the deep fake.
I would just caution how early we are in this whole innovation cycle. So if we start seeing outcomes or real products that are impacting either patients' lives, clinicians, workflows in significant ways, then all these kind of details we're talking about in the background, whether it's reinforcement learning or synthetic data or whatever, will disappear into the background along with the technology. What people need, what people really care about is, are you going to make me healthier? Are you going to help the process? Is it going to cost less? Is my job going to be easier? And I believe that's where the real magic opportunity here is, augmenting our clinicians, augmenting patients so that they can either get better access to care or better outcomes in their lives. And I just think we're so early in the healthcare component of this innovation cycle, which is where to me, the real excitement is over the next, let's call it 3 to 5 years.
I want to say you did a beautiful job for us. You need just putting a big bow on this wonderful hour we spent together. I'm not going to go anywhere from there because that was just perfect. And so I want to start with thanking you, Unity, for taking time out to join us today. Unity Stokes from Startup Health. Phenomenal. Thank you so much for your insights, your perspective, and everything you've contributed this morning. Thank you.
Thank you.
Dr. Peter Schilling, old friend, great researcher, and thank you for contributing to our session this morning as well. Thank you for coming and joining us.
My pleasure.
And Prashant, H2O.ai, third largest AI company. You said something along those lines, and right now working.
Oldest and largest AI ML company, world's, I would say, most prominent open source movement. And we encourage your audience to join us.
An open source movement, we thank you for that, because this is what's making these technologies accessible to many of us. So thank you all for a wonderful session. We're going to call it a day. We'll make this accessible to everybody in a few days on our website at docsf.health. We invite everybody who's interested in this sort of topic to think about joining us at our annual conference. Next year will be in October 2024 in San Francisco, and to follow us on our podcast. We have the conference topics from this past year that were actually exceptional, and this webinar will also become a podcast in the next couple of weeks. Gentlemen, thank you so much.
Thank you.
Thank you. Bye.